Alright, so this problem says a pulse can be described as a single wave disturbance that moves through a medium. Consider a pulse that is defined at time t equal to 0 seconds by the equation 6 meters cubed, 6 divided by x squared plus 2, centered around x equal to 0 meters. This pulse moves with velocity of 3 meters per second in the positive x direction. What's the amplitude of the pulse? What's the equation of the pulse as a function of time? What is the pulse? Where is the pulse centered at time t equal to 5 seconds? Okay. So here's the pulse. I'll use a little simplified notation. There it is. And you can check, you can plot this on a graphing calculator or whatever, and the pulse will look something like this, sort of a bell-shaped curve. Okay, with the amplitude being at x equal to 0, so this is the pulse at t equal to 0, and it's centered out, its peaks at x equal to 0, and you can calculate for x equal to 0, this would be 0, and the amplitude of the pulse would be 3 meters. Okay, so the amplitude is y at 0 is 3 meters. And now to get the equation as a function of time, what you need to do is replace x by, in this equation you replace x by x minus vt. Okay, that's if it's to the if the pulse is traveling to the right, and if it was traveling to the left, you would replace x by x plus vt. Okay, so the equation for the pulse now is 6 over x minus vt squared plus 2, again in meters. Okay, so, and for part C, where is the pulse centered at time t equal to 5 seconds? So it would be centered at velocity times the time. So so the pulse is at 6 divided by x minus 3 times 5 plus 2. Okay, so x minus 15 squared plus 2. So the pulse is centered at 15 meters. At 15 meters. Okay, that finishes that problem.